Good day, my students. I welcome you back to Eko Learners Support for WAEC and NECO candidates. My name is Udusatulokwe Joseph. I'm your instructor for today's class. I want you to just sit back and let's enjoy this class together.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
What are we going to be discussing today? Don't mind my screen. This is just to show you that you are in what? A chemistry ward. Let's go together. Fine. Our variable objective for this particular class will be 1. Define hydrocarbon. Good. Describe the properties of organic compounds. 2. Then 3. To list the components of crude oil. I promise you, it's going to be an interesting class. Just make sure you flow with me as we go on with the class. Fine. You wanted to ask me before, so I'm asking you now. What is it called? Have you seen this picture before? Maybe you've not, but you've seen that image before. Oh, good. That is activated charcoal. What does it contain? Carbon. So our bone basically contains what? Carbon. It contains carbon. And carbon is so essential when it comes to what? Organic compound. Basically, hydrocarbon. Precisely. Now, what can you see there? That is a what? Oh, that look like a cooking gas with a blue flame. It's coming from where? Oh, that is one of the what? The source or sources you can get from crude oil, natural gas. What we use to cook at home. Called what? Tell me again. Methane, yeah. Yes, that is methane gas. We use it to cook. It contains what? Carbon also. Do you see? The carbon is getting more interesting. It's very important in day-to-day what? Activities. Okay, if that is fine, we will establish that carbon is so essential for us. Then we need to learn more about carbon in order to have a better understanding of what? Organic chemistry. Good. Oh, I have this for you. Maybe it will wow you. Let's go into the video together. Okay, fine. Basically, it's talking about methane, the natural gas. The one that he said it contains what? Carbon. Okay, fine. Wow. Are you still playing? Oh, good. Yeah, it's still playing. So let's see. Basically, what do you see? He's showing us the what? The electronic structure of carbon. That is what structural formula of what we call a natural gas. Methane is showing what? The electronic what? Arrangement. Don't just worry, I'm going to explain in details to you. Well, showing a chemical reaction. Fine. I hope you are following me. Good. Wow. What do you see? These 3 dimensions of what? Of the structure of carbon. Don't be carried away. We need to let you know the shape is tetrahedral. Meaning it has 4 legs. Just take it like that. And it is basically called tetravalent element. Tetra means carbon must always be supported with how many legs? Permit me to use the word leg. Okay, good. 4 legs. Okay. But it's showing the what? The 3 dimensions of that particular structure. Okay? Fine. The question being asked is, oh my God, what is catenation? Catenation is just the ability of what? Carbon to combine with another what? Carbon to combine with another what? Carbon to combine with another what? Carbon to form a longer chain. of what? Carbon. Oh, is it only carbon that can do that? Scientists say no, other elements can do that. But these special properties of carbon is called catenation. So when they ask you what catenation, it's just the ability, you understand, of carbon to combine with itself to form a larger what? Compound. Basically, when you see what I put there, it has the ability to form a single, a double, or a triple what? Covalent bond between the atoms. Oh, I need to explain that. A large amount of energy is required to break, yes, carbon single bonds. What does it mean to you? Permits me to move up and down because I want you to understand. Let me see if my pen, oh, my pen is peaked. Okay, fine. Carbon, you can have something like this neighboring atom. This one is called, I hope you still remember, okay, methane. When you look at it, this kind of bond is called a single bond. You can see a single bond between carbon and what? And hydrogen, a single bond. It has the ability to do that. And they are more saturated. Why? It requires a large amount of energy to just break this bond. If I were to break this bond, it requires a lot of energy to do that. It requires a lot of energy. Why? Because it's more stable. Then it can come in this way. Yes. So this is called what? You remember what this is called? This 18. 18? Where is it coming from? God. Don't worry, it's coming from the family called alkenes. You are still going to understand it better. It's forming a double bond. Don't forget, I told you, carbon is a tetravalent element. The leg of carbon must be 4. Look at it. 1, 2. This 1, this 2. How many here? You have 2 here, making what? 4. So the bond between the carbon is double. He has the ability to do this. It's double bond. He has the ability to do this. Let me assist you. The hybrid here is sp3. The hybrid here is what? sp2. Then he can decide to form something like this. You can decide to form something like this. This is what we call what? Ethyne. Say it again. Ethyne. Oh my God. Why is carbon doing all this to me? Don't be worried. It's just from the family called alkyne. Alkyne. You get to know this as we move on with organic chemistry. Yeah, don't be panicking. Just get relaxed. Make sure you are following me. And don't forget, I told you, it's a tetravalent element, so it has 1, 2, 3, 4. 1, 2, 3, 4. So what kind of bond is this? What kind of hybrids is this? Is sp. Hybrids. It's forming what? Sp what? Hybrids. So this is a what? A triple bond, rightly said, a covalent what? Triple bond. So what do you mean by covalent? They are sharing what? Electron. So there's a share of electron between carbon and carbon, carbon and hydrogen. And don't forget as well that the hydrogen is what? Univalent element. Meaning it has one electron to be shared with the neighboring atom. But in this case, by what we call a covalent bond. Okay, fine. We can move on. And when they say hybridization and when they say catenation, I've told you what the catenation is, ability of carbon to combine with itself to form a larger carbon. Then hybridization is the process whereby different orbitals of different energy level combine together to form a what? Another new set of what? Orbitals of the same energy level. I wish to illustrate this. Let me see, but it will take a longer time to do that. And we might not be able, but don't worry, in my next class, just make sure you are following me. I'm going to talk more about hybridization. But get to know that hybridization simply means I have orbital, this x orbital, combining with this is what we call what? P orbital. Yes. So this s orbital combined with p orbital to form something in this particular direction. This x and this p, there is forming sp what? Orbital. This orbital will have the same energy. Why this one has different, the energy here is different to the energy here. So hybridization simply means combination of two or more different orbitals together to form a new set of orbitals with the same energy level. I hope you got it. There's one condition we normally put in that definition. The lowest energy don't take part in what? Hybridization. Fine. Can we move on? I hope you are not confused. Okay, fine. Let me go back and explain catenation. Carbon combined with another carbon to form a larger carbon. Don't forget that. Then hybridization, different orbitals of different energy level combined to form a new set of orbitals without a new set of what? Orbital with the same energy what? Level. Good. Let's move on. I can move my screen now. So what are the characteristics? Yeah, future of what? Organic compound. Basically, when I say organic compound now, we're talking about carbon with other elements. It could be hydrogen, and oxygen, or nitrogen. What do you see on the board? This is crude oil. Do you know that we have crude oil in Nigeria? Oh, good. You will have heard about Dangote refinery in Lagos State. Fine. What is Dangote doing? What? In Lagos State, it's extracting what? Crude oil. In order to provide us with what? Petrol, diesel, other what? Components. They are called what? Non-polar what? Substances. Non-polar what? Substances. Oh, sorry about this. I've not picked my pen. Let me see if I can pick my pen here. Okay, good. They are called non-polar substances. I hope you know the meaning of non-polar. Don't go too far. Just get a word. You might not be able to get a crude oil, get a oil, put oil in water, with the oil dissolve. It won't. Why? Because the oil is what? Non-polar. Likewise, crude oil is a non-polar. So it's not what? Soluble. In what? In polar solvent. Yeah, what are the examples of polar solvent? You have water. Water is an example of what? Polar solvent. So it won't dissolve. Get to know now that what? Crude oil is what? Is a non-polar substances or compound and doesn't dissolve in what? In polar solvent. Is that clear? Another word for not dissolving is what? Insoluble. Insoluble. There's another word for what? Not dissolving. Good. You grab that. Let me see if I can take my pen here. Oh, my pen is not coming, so I have to move back to here. Then pick my pen and erase all and come, undo. Okay, fine. What can you see? Normal what? Pentane is an organic compound. Yes, you might be wondering, normal pentane is an what? An organic compound. Although, if you want to scale it down, you can say hydrocarbon. Fine. Hydrocarbon is see what? An example of what? Organic compound. What again can you see there? The crude oil is an example of what? Organic compound. And we'll talk about it. They have low melting and boiling points. Unlike water, you know water has high boiling points. It boils around 100 degrees Celsius. So he's saying if you put oil and water together, which one will boil first? Is the oil. Why? Because it has a low boiling point. Getting the logic? Fine. This is more dangerous. What do you see here? It catches fire easily. Don't try it. I would have suggested that you take a petrol, move it close to what? A cooking gas. But don't do that. Why? Because it catches what? Fire easily. Don't do that. They are highly what? Flammable. So when they are carrying them with this inside tanker, they normally put it highly what? Flammable. Meaning, don't ever try to play with them with fire because they catch fire easily. These are the properties that you need to know. Okay, let me move on. I want to be sure. Fine. You have isopentane, still belongs to the what? Organic compound. Yeah, their reactions are relatively slow compared to what? Inorganic what? Chemical reaction. You might be wondering what is inorganic chemical reaction. The first one is the reaction with the formation of water. We have hydrogen, we have oxygen. And that reaction is very fast. But in this particular case, their own reaction is very, very what? Relatively what? Yeah, relatively what? Yes, slow when you compare. Then you ask yourself, why? That is the question, because they require large amount of energy to break their carbon single bond. I told you earlier that the bond between them, between carbon and carbon, can be single, can be double, and can be triple. So in this particular case, for you to break their bond, it requires a lot of what? Energy. And that's reduce their reactivity when it comes to either being fast or being slow. So yeah, they have a slow reaction. Why? Because it requires a large amount of energy to break their bond. Am I moving? Am I flowing? Are you following me? Okay, good. If you are, good. Classification of what? Organic compounds. Classification. Can we classify them? Yes, why not? We can classify them. Because normally, everything should be classified. Good. So which one is aromatic hydrocarbon and which one is what? Aliphatic hydrocarbon. So that is the question here. You can classify them under aromatic, under what? Aliphatic. And you can still come down and say the hydrocarbon can equally be classified into aromatic and aliphatic. But I want you to know at this point that when they say basically hydrocarbon, it means carbon and nitrogen only. But when they say organic compounds, it means carbon with other what? Elements, which could be hydrogen, oxygen, nitrogen, as the case may be. Good. So which one? I'm asking you. You're telling me the answer? Let me pick my pen. Okay, fine. Yes. This is what? Aliphatic. Why is it aliphatic? Because they don't contain what we call benzene what? Ring. Benzene ring? You might be wondering, what's benzene ring? You know this shinab. I want to remember the name of this shinab. Forgotten the shinab that we use when you want to do naming ceremony, or you want to do wedding. You have to go and buy that shinab. Okay, don't let us go into shinab. But get to know that they are aliphatic because they don't contain what? A benzene ring. How does the benzene ring look like? Let me help you a little. A benzene ring look like this. This is a benzene ring. So when you see an hydrocarbon without this benzene ring, we classify them as what? Aliphatic. What? Aliphatic. Yes. We give them aliphatic hydrocarbon. So this aliphatic hydrocarbon could be single, could be straight chain, branch chain, or cyclic. Why this? Yes, this is aromatic. Why? Because it contains a benzene ring. And no, it can resonate. Yeah, and discovered by what we call Kekuli. Kekuli. Get to know the name of the guy that worked on the Kekuli. And it can what? Resonate. Resonate is very key. Yeah, we don't have plenty time. Let me move. Can we move? So let's go to the next slide. Oh, the terms that we use. Yeah, that's what we call homologous series. So what's the homologous series? You need to understand because everything must have what we call trend. We have origin when we all came from. Okay, fine. So they too, they have their own origin. Homologous series is a family of organic compounds which follow what? Irregular what? Structural pattern in which each successive member differ by its what? Molecular formula called what? CH2. Examples of these: alkane, alkyne, alkanol, alkanoic acid, and etc. Let me just quickly explain a little about this, and let me pick the family one. So let me pick a family of a family of alkanes. with the general molecular formula of this 2n plus what? 2. So when n is 1, you have CH4. When n is 2, you have C2H6. When n is 3, you have C3H, that is what? 8. So between these two successive members, you discover that you have what? CH2. True or false? Yes. You can remove what? 1 carbon from 2, you have 1. 4 from 6, you have 2. Between these successive members, you have CH2. So this is what we mean. So each successive member must be different by molecular formula called what? CH2. And that is what we call homologous series. So these are examples of homologous series. Good. So let's move. Yeah. There is functional what? Groups in organic what? Compounds. So what are the functional groups? Yeah, functional group is what? Is an atom or group of atoms. They are never radical. Because in WAEC they've asked and students put radical. You won't see radical among them. Is it like atom or group of atoms? We determine the what? The characteristic chemical properties of a particular class of what? Organic compound. But what you need to know at this point is, good, they are atom or group of atoms, or bonds. Yeah, you can see bonds that determine the chemical properties of organic compound. And these are the examples. So we have the single for the alkene. You see, for the, oh, let me pick my pen so you'll be able to understand what I'm saying. Yes, so you have single bond here. Here, alkenes, you have what? Double bond. So these are the functional group that actually determine how the organic compound is going to react, telling you that they are so essential. Then this is what? Triple bond. This triple bond. Then this one is what? OH, the hydroxyl group. These are the what? Their functional group. And they are so essential when it comes to how the organic compound will react in a chemical reaction. So this is basically the crude oil. What are they trying to do? They're trying to what? Explore it from the what? Underneath. So you have the one onshore, you have the offshore. The one that they extract from the ground is called what? On. The one on the water is called what? Offshore. Good. So this is what we have here. And these are the fractions of what? Crude oil. We are still going to talk more about it when we talk about fractional distillation of crude oil in the next class. But basically, get to know the product obtained from the crude oil. So this is what offshore is being explored on the water. So we have to end it at this point. Everything we've said is around hydrocarbon and organic compound. Therefore, you have any question, any comment, or any suggestion that you think can improve the teaching and learning of this particular topic, you can reach out to us on the information display on the screen. I remain Odusatulokwe Joseph. See you in the next class, and bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.